All right, guys, we've come to the end of our series. This is the last, chapter 12 in this book we've been doing for I don't know how long. This is the last one. The subject today is recursion. Okay, this is something we've seen briefly before. It's both simple and profound at the same time. It's simple to do and it's profound to use. Recursion is simply a function that calls itself. That's it. And we saw that when we were talking about, what was it? It was one of the sorts, I think it was, where you divide everything into smaller bits and then you call itself to handle the smaller bits, right? Forgot which one that was, but that's recursion. So let's define this a little more carefully. Let's say we have an array r equal to new int 100. So we got a huge array, or huge, 100. You got a larger array, and let's pretend we populate it with a bunch of stuff. And you could do this with simply with a for loop, right? That's pretty easy, no problem. We've seen that. You could do it with any kind of loop, really. But just for illustration, we're going to try to see if we can figure out how to do this recursively. So to go through here, and what we're going to do is try to find some value. So we're going to say int target equal to 5. That's the value we want to find, and we want to return the index of that. So public int find int t int I. Okay, so what's going on here? T is the target, so we're passing in the target. We're going to find the target, and I is the index into the array. So the array is going to stay up here. It's not a good design of a function. We shouldn't do it that way, but this is for illustration purposes. So we'll say something like this: if I is greater than or equal to r return -1, else if r I is equal to t, return I. Else find t I plus 1. This is a simple recursive method. Okay, and I'm going to point out a couple of key things about it. It's recursive, we know, because down here it calls itself. Okay. The most important thing I want to point out about this function is this first bit. You must be very careful. Even though functions calling themselves is actually very easy, you have to be very, very careful that this chain of calling itself has an end. If it doesn't, it'll just keep calling itself forever until something blows up. So this is how we end it. What we're going to do, and I'll explain this in a second, but what we want to do is just start off with I. We're going to say something like find target 0. Okay, so we're going to start with 0 when we call this thing, and so we start with 0, and we want to just look at what's in that array position 0. If it's not it, then call it again with the next one, I plus 1, which would be 1, then 2, and 3, and 4, until we find it, or until we run out of array boxes, elements. So this is what this first if statement is checking. Are we done? Yes.
Doesn't the find thing need 2 things passed in?
Yes. T and I plus 1.
You only pass it 0
Hmm? Where?
in the find.
Up here?
Yeah,
0 is an integer.
that's just 1.
Target.
That's not an integer.
Yes, it is.
Oh, you
Target
target
5.
never
So
mind.
there's a 5 and a 0.
Never mind.
I just use variable.
Hmm.
So that's valid. Okay, so basically, the first thing I'm gonna do is see this I that I'm passed in, that's an index, is it greater than or equal to the length of the array? Am I off the end of the array? If I am, that means I haven't found it, so I return -1. -1 isn't a valid array index, so if you get -1 back from your top level find call here, I think it's called the base, the base call. That's what your book calls it, the base call, the first one. If the base call returns -1, you know it wasn't found. Okay, but it's critical when you're writing a recursive function to make sure that you have some condition that stops the recursive behavior. Don't let that go on forever. Okay, so that's right here. So if we get to if this I passed in is greater than or equal to the length, we're done. So if we get past this into the else, that means nope, we're not at the end of the array. So let's see if we found it. So if array sub I is equal to our target, return I, because that's the index that we care about. So it will bubble up and return it up here. Great, we found it. So it'll either return -1 or the index that it found it. Now, if we're not done and it didn't find it, what do? We call find again with the same target, but I plus 1, the next item of the array. We just keep doing it. Now, this is silly because it'd be easier just to write a for loop. But there are other problems that this is actually a very logical way to solve the problem and think about a solution. So recursion is actually a very handy thing. I just wanted to keep it really simple for the sake of an example. Does this make sense? So function calling itself, some condition that stops that recursive behavior, and then whatever the behavior you want is right there. Okay, I think that's the end of recursion. Let's just double check. Yeah, I mean, your test is going to have something that has you tracing through a recursive problem, and so it's a little challenging. You'll need a piece of paper to figure that out, but in principle, that's all it is. Hope you've enjoyed this series. Apologize that sometimes the whiteboards aren't so clear and easy to see, but hopefully you learned something. More importantly, hope you do well on your AP Computer Science A test. Good luck.